This video will break down the safety requirements for the use of powered industrial trucks. It will cover essential training for new and experienced operators alike, and is based on OSHA 29 CFR 1910.178, and will also refer to information from the American National Standards Institute, the Industrial Truck Standards Development Foundation, along with some common sense. Available links are in the description to continue from this video with practical, organizational, and site-specific training, and it's meant to help craft a full and complete PIT training program. I'll be making annotations in the video for some of those things that can really only happen IRL, or where requirements may need some customization beyond the letter of the standard. So stay tuned and let's dive right in. A powered industrial truck is any mobile power-driven vehicle used to carry, push, pull, lift, or stack materials. These vehicles are categorized and regulated under OSHA 1910.178. It's interesting to note that not everything with the abilities of that definition are necessarily covered under this standard. Okay, so what does that mean? It means basically vehicles like tractors, skid steer loaders, and other common industrial machines that can have forks for moving and lifting materials are specifically excluded from 1910.178. It doesn't mean their use isn't regulated, it's just that this is not the standard that you're looking for.
Move along. Move along.
There can be more than one standard that applies to those types of vehicles, so we'll leave that topic for another time and stick specifically with defined PIT vehicles. The basic components of a PIT include forks, mast, carriage, counterweight, controls, load backrest, attachments, and overhead guard. To operate a powered industrial truck legally, OSHA requires that operators be trained and certified. Operators must be 18 years or older, have completed operator certification training, be re-evaluated every 3 years post-certification, and complete immediate retraining after an unsafe act or operation. Operator certification must include at least formal instruction, practical training, and a performance evaluation. Technology hasn't yet reached the point that those last two can be covered at all on YouTube. Operating without proper documented training and certification is a significant OSHA violation, even without a reported accident or injury.
We interrupt this program to bring you a special report.
I haven't brought this up specifically on any previous video, but this seems like a great time to do it. Keep in mind that these are just potential fines, and actual penalties can vary depending on factors like the employer's history, gravity of the violation, and the company's size.
And now back to your regularly scheduled program.
So what documentation of training is sufficient? As EHS professionals are very fond of saying, if it's not written down, it didn't happen. But here's the brass tacks. Employers must document all operator training and evaluations. This documentation must verify that each operator has received the necessary training and has been evaluated on their practical ability to safely operate each of the 7 basic classes of equipment that they're being certified on. The certification must include the operator's name, training and certification date, most recent evaluation date, and the name of the trainers and evaluators. Note that there is no OSHA requirement mandating the need for an operator's license to be available for presentation, but depending on the size of the organization and operator turnover, this may be something to consider adding to make verification much simpler in the field. Before powering up, a pre-use inspection is required and must occur before every 24 hours of operation or prior to each operational shift. Pre-operational checks should consist of at least physical checks of the general condition of the tires, forks, mast, and attachments, checks for leaks or signs of leaks, verifying that the load capacity plate is present and clearly readable, signs of defeating safety equipment, checks of the operation of all lights, horns, and alarms, steering and brakes, checks and rechecks of seatbelts and other safety systems equipped, and all vehicle controls. On top of corrosion from battery leakage being a serious issue, the buildup of hydrogen, oxygen, and other gases from a leaking PIT battery is exceptionally flammable, explosive, and toxic.
So this is our hydrogen oxygen explosion. We have a 2-to-1 ratio of hydrogen gas to oxygen gas. I like this. This should be incredibly loud. Once I like this, it's coming like that. So cover your ears, please. It's loud.
Additionally, a missing or unreadable or altered plate alone will require the vehicle to be taken out of service. There may also be additional requirements based on the type of truck and the manufacturer's recommendations. If there are any problems noted during pre-op checks, take the unit out of service immediately for maintenance. While there is no specific language requiring these inspections to be in writing or retained past the current operating period, a written and retained record of these inspections is highly recommended. Not only will it help you investigate incidents with the truck, it also provides a sort of health report for the vehicle over time. Small issues that don't necessarily impact the safe use of the vehicle may end up on these reports and help make a case for a preventative maintenance schedule, and preventative maintenance is safe operation. Safe operating basics. Number 1. Always wear your seatbelt. I spent some time in a hospital bed once, and my first roommate was the victim of a pit accident. His leg was crushed to the point that he had hundreds of pins holding him together.
Watch this piece of footage I found on the internet.
Based on his description of the accident, he couldn't have been wearing his seatbelt. Another accident, this time that I investigated, consisted of a rollover event. If that operator had not had their seatbelt fastened, they would have fallen out of the truck and the truck would have rolled over them. Look, just wear your damn seatbelt. I really shouldn't have to say anything more than that. Number 2. Keep the forks low when traveling. No more than 4 to 6 inches above the ground for most conditions. The best way I've heard to describe the effects of the sheer mass of these vehicles is this. Consider an average sit-down type forklift weighs in the vicinity of 8,000 to 15,000 pounds. Now consider most of the mass concentrated into the tiny area of an empty fork. There's enough mass condensed to that point to snap a human femur like a twig at less than 1 mile an hour. And that doesn't even take into account other forces that act on a mass that size in motion. Number 3. Maintain visibility at all times. This means that your head and eyes should be facing the direction of travel at all times. Mirrors are good for reference. Number 4. Sound the horn at all intersections to avoid collisions. Number 5. Never engage in horseplay or reckless driving. Number 6. Pedestrians always have the right of way. Period. Yeah, some of them can be frustrating, but the human body is a grape compared to the mass of even the smallest pit truck. Even for expert operators, things can go bad very quickly, and maintaining safety discipline in just these few points can make a huge difference. Proper load handling is vital for safe operation. Load handling requirements include never exceeding the rated load capacity. There is no attachment or anything that can make a pit lift, carry, or move things above its rating safely. Centering the load and approaching it squarely. Slightly tilting the mast back.
That's what she said.
Not raising or lowering the mast while in motion. Look, I've done it, you've done it, but remember how much mass you're dealing with here. Ensuring that the load is evenly and appropriately distributed, and always keeping the load uphill when traveling on inclines. A huge number of pit accidents stem from improper loading or turning with elevated forks, so now I'll take a few moments to talk about the basic physics involved with load handling. Some of it is kind of intuitive, but it's certainly worth discussing. If you're a seasoned operator or newly trained, I sure hope you're familiar with the triangle of stability. If you're not, the concept explains the changing center of mass of the vehicle under different conditions. It goes without saying, and I'm going to say it anyway, pit vehicles are designed to lift and move some very heavy things, meaning that they themselves need to be heavy to counterbalance the weight of the load. The specific center of gravity for each pit will be a little different based on what it's designed to do and its manufacturer, but a good general rule is that it's a point usually near the mast where the truck, fully loaded, will be balanced. For this video, we'll consider this in only 2 dimensions, forward and aft. This is the point past which even a properly distributed load will cause the vehicle to become unstable and potentially tip. This means that the stability point is moving as you lift the load, move the load, or try and stop the load. Now, I could say something trite like keep this in mind, but being able to feel this change is one of the biggest things that can only come from general operator experience and experience with each individual truck you operate. Thankfully, there have been some technological advancements and sensors that make this easier on operators, but how many trucks out there are brand new and state-of-the-art? Each truck certainly has an engineered triangle of stability, but how that actually translates into real operation in the real world with real loads under real conditions takes some time. So especially if you get a new truck or you're a new operator, get to know your vehicle, get to know its limitations, and get to know the way that it tells you that it's about to have a problem. Now, I said at the beginning of this section we were going to talk about triangle of stability in 2 dimensions, but the triangle of stability is in all 3 dimensions and moves with the height of the load, the speed of the vehicle, how quickly or sharply the vehicle turns. A lot of different factors contribute to where the center of gravity is in relation to that triangle of stability, or really pyramid of stability if you think about it in 3 dimensions. Every year, OSHA reports around 80 to 100 fatalities and thousands of serious injuries involving powered industrial trucks. Their top hazards resulting in those injuries are tip-overs or rollovers, struck-by incidents involving pedestrians, falling loads, falls from the operator platform, the seat or operator's position, falling from forks, and crushing accidents. I've addressed some real-world examples of some of these, but I want to address in this section falling loads and crushing accidents. When I was originally trained as a pit operator, it was at a time just before a competing business. A big box home improvement center had an accident that pushed a top stock pallet onto a customer as an operator was attempting to place an item on the same shelf of the opposing aisle, killing the customer instantly. There were a lot of things wrong with that situation, but the root of the issue in the moment was that there was no spotter present for a space the operator couldn't see. So I can't overstress using spotters when necessary, particularly when visibility is an issue or where there's some kind of an issue with the load and you're not quite sure what it's going to do. Don't take shortcuts. When exiting any pit, follow proper shutdown procedures outlined in OSHA 1910.178 M5. Fully lower the forks. Set the parking brake, shift to neutral, turn off the power, and remove the key. Unattended powered industrial trucks must never be left running. Under OSHA, the truck is considered unattended if the operator is 25 feet or more away, or if the truck is out of the operator's direct line of sight. For a moment, as I wrap up this video, I'd like to take a second to talk to any experienced, dare I say it, expert operators out there that may have scoffed at some of this video. Being an excellent pit operator is a point of pride, and it should be. It takes a lot of experience, practice, and skill to operate safely, accurately, and efficiently. Heck, when I was first trained as an operator, the trainer would end each training period by bragging that he could pick up a dime with a forklift. Now, he certainly wouldn't demonstrate it or tell us how to do it, of course, but it did make more than one of his students try in some very sketchy ways. He dropped that brag shortly after a minor accident. Later, as a safety and health professional, I've had all manner of cases presented to me as to why I should be able to do it my way because I'm that good. One of the more memorable ones was an operator and trainer justified that they could drive faster than a newer operator in the facility because they are operating at what basically they described as an F1 racing driver level compared to other operators. I'll let you guess the response that I had to that one. Keep in mind that whether you're a trainer or not, whether you have a lot of experience or you don't, you're not only an example to the newly certified, you can also be a challenge to be better. And nothing is more dangerous on a pit vehicle than an inexperienced operator trying to do something above their skill or comfort level. There's certainly a lot I didn't cover in this video about the practical aspects of pit operation because simply I can't. Not on a YouTube video. The vast majority of safe operation is baked into the needs of a facility or worksite, the requirements of the specific equipment being used, vehicle manufacturer requirements and recommendations, and so many other things that the generalizations begin to become ineffective. A powered industrial truck safety program and its training program should be carefully crafted, thoughtfully considered, and updated regularly, but it's at least one topic on which OSHA has spent a lot of time and resources and offers some very specific guidance. And it's because there's not a lot of margin of error for these vehicles. So much could go so wrong so quickly and so permanently that OSHA has spent a lot of time and resources over the decades making sure that their program is very specific with what they're requiring of employers in the United States. But as for this video, these are my parting thoughts. Know your equipment, inspect it, load it and unload it carefully, drive with awareness and care, follow the standards, stay certified, and stay alert. Every move you make with a powered industrial truck should be intentional and safe. Thanks for listening. If this helped you, leave a like, subscribe, and maybe share it with your team. If you have any questions about the content of this video, or there was something major that you think I should have covered that I didn't, please drop it in the comments. I look forward to seeing you in the next video.